this chapter is, in general, or this unit rather, is all about functions. And functions are relationships. We're connecting x to y somehow. We're looking at how are the variables x and y related to each other. And there are two special types of relationships between x and y that have particular names. There are other relationships that have other names, but this video is about direct and inverse variation. These are types of relationships that actually show up a lot in real life when you are looking at how far you go at a certain speed, or how many gallons of gas that you'll need in order to go a certain distance, or how much it costs to go get on an airplane and fly a certain distance, or how long it will take a group of people to paint, or any number of other things. Those are all examples of direct and inverse variation. And the difference generally is that direct variation is really, it's like the linear graphs that you've been making. In fact, direct variation is a linear relationship, but specifically one where the y-intercept, b, is equal to 0. So we would have y is equal to just m times x. The y-intercept is 0. And think of it again, if you're driving at 0 miles per hour, it means you're not moving. So it doesn't matter how long you sit there at 0 miles per hour, for an hour, 2 hours, 3 hours, you're not going to go anywhere. So there's no y-intercept. When x is 0, then y is 0. When we're talking about direct and inverse variation, though, we don't usually use m, we use k. And k, in this case, stands for the constant of variation. Why do we use k instead of c? C being for constant, is a good question. And it's mostly because we want to make sure that it's that hard k sound. It actually comes from German. I don't recall what it's spelled like, but the hard K sound needs a K, an actual K character. We can't use a C because that's, like in circus or other words, circle, that have that softer C sound. We just go with K. And K stands for the constant of variation. Another way to define K here that's very useful is to just say that K is equal to y divided by x. This will be a useful way for us to remember that. For inverse variation, it's all the opposite. First of all, inverse variation is nonlinear. We don't get a straight line when we're looking at inverse variation. It's not like direct variation is a line that is increasing and direct variation is a line that is decreasing. When you graph a case of inverse variation, what you'll actually get is kind of a weird looking graph like this. And you can check that out on your calculator once we get the example. But generally, the formula for an example of inverse variation looks like, let me scroll this down a bit. The formula for inverse variation is y equals k divided by x. For direct variation, we have y is equal to k times x. For inverse variation, we have y is equal to k divided by x. And then putting it the other way, we could also say that k itself is equal to y times x. And these two pairs of formulas, they're very useful for determining the difference between inverse and direct variation. So in the next videos, we'll look at some examples of how these are used, but these are the general definitions. Direct variation, y is equal to k times x, or k is equal to y divided by x, whatever y and x are. For inverse variation, y is equal to k divided by x, and k is equal to y times x. So really, it's the same kind of idea, they just get swapped around for the two different types.